Okay, so let's solve the first one here. So these guys, we push them in, and they're right next to each other, 34 centimeters apart, right? And we release them, and later they are 50 centimeters apart, and they're going to be moving, right? So the question is, how fast are they going, right? So initially we've got some potential energy, right? And then afterwards we'll have potential and kinetic. Now, because they're released simultaneously, because they have the same mass, but not necessarily because they have the same charge, they will have the same velocity and they'll split the kinetic energy evenly. We can solve this simply because it's symmetrical. Were they not to have the same mass, we would have to use conservation of momentum simultaneously with conservation of energy. But I don't think we have to worry about that in the IB test. So let's just see what this does. Okay, so initially we've got just potential energy, right? So we've got K, so 8.99 times 10 to the 9th times 45 E minus 6, right? Times 45 E minus 6. And then divided by 0.34. So K QQ over R is our potential to begin with, right? And then we have no kinetic energy to begin with. And then afterwards, we're going to have K times 45 E minus 6 times 45 E minus 6 over 0.50, right? This will be a smaller number, so therefore we're going to have some kinetic energy, right? Okay, so we'll have kinetic energy, right? So 1/2 mv squared plus 1/2 mv squared. And these will be equal, okay? So we could just say 2 times that, right? Okay, so let's figure this out. This term here is alpha F1. It's alpha K. I just stored 8.99 times 10 to the 9th in there, times 45 E minus 6 times 45 E minus 6 over 0.34. So this term is 53.543. And then this term here, all I have to do is reuse that same guy, only make it 0.5. This is 36.4. And then plus 2 times the kinetic energy of these guys, right? So let's subtract that. Let's go this guy minus this guy. I'm getting that 17.133 is 2 times the kinetic energy that each one gets, right? Okay, so let's divide this by 2. And I'm getting that each one of them has a kinetic energy. So 8.5669 is equal to 1/2. And now we can use the kinetic energy of one of the masses. 0.056 times v squared, right? We don't know v squared. Okay, so times 2 divided by 0.056 raised to the 0.5. That's 17.5 meters per second. Now that is just when they are 50 centimeters away. In the next video, I'll figure out when they're very, very far away, right? They're very, very far. How far? So far.